Test, 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 test.
Okay, cool. It's got a little red lights, which is a bit hard to see. Okay, that's all. Cool, thanks. Yep, hello, hello. Perfect, cool. Yeah, thank you. Okay, I think we're...
I think we have a second mic, so if anyone has any questions, can you just repeat it into the microphone so that everyone in the recording can hear as well?
Okay, perfect. And I think we're at time, so I'll get started?
Absolutely.
Okay, cool, thank you. Okay, hello everyone. Hi, I'm Jeff McDonald, and along with Mustafa, Bhavna, Jugal, and Andreas, today I'm going to be talking to you about a Windows 10 feature which has AMSI integrations for script behaviors and how we're using it to create machine learning protection as well. So how you can use these behavior logs with machine learning to provide customer protection for your customers as an AV vendor or as an enterprise as well. So I'm out from the Windows Defender AV team. So I work as a machine learning researcher for Windows Defender AV, where we build models and pipelines to protect our customers using machine learning. Although I come from a background more of reverse engineering malware and doing more deep technical analysis. Okay, so first a little bit about the script threat landscape. Probably a lot of you are very familiar with what these malicious script attacks look like. So they're used in a variety of stages of attacks. So one of the most common ones is in social engineering attacks. Usually these type of attacks will be archives that are attached to emails as phishing lures to customers. And then within that email archive, there'll be a JavaScript, a Visual Basic script, or an HTA file, which they try to trick the user into opening. But these malicious scripts are used more than just as the initial infection vector. They're used a lot as stages in attacks after getting a foothold on a machine as well, especially when they don't want to write a file to disk. So they're commonly used in fileless attacks, both as stages during the attack to avoid writing files to disk, but also as a persistence method on infected machines, where they'll actually set up malicious script content in a registry key, and that's the malicious execution point. They're used a lot in advanced attacks as well, specifically on the PowerShell front. There's entire red team frameworks and penetration frameworks built around PowerShells, such as PowerSploit, for example, and it's one of the choice tools for lateral movements after infecting the network as well. So scripts, when they get executed on Windows, get hosted in script execution engines. So it depends on what type of script you're dealing with. If you're opening a Visual Basic script, for example, it would be hosted with WScript or cscript.exe on a Windows machine. And it's fairly similar for JavaScript files as well. It would be hosted in WScript or cscript.exe, which are Windows script execution engines. HTA file is an HTML application, and it's also one of the very commonly targeted script types that you see in social engineering lures, and that gets hosted with mshta.exe. So social engineering attacks often rely on these scripts, as I said. So this is a quick example of what one of these attacks look like. So in this case, they're saying, hey, please refer to the attached invoice. Now, if the user were to open this archive file, inside there would be a Visual Basic script file. Now, if the user were to run this, it's obfuscated and packed Visual Basic script. They usually change their packing methodology per campaign weight, per attack weight that the attackers carry out. So they'll create a new packer for the Visual Basic script or JavaScript. They'll test it against all the AV vendors. They'll make sure it's not detected. Then they'll carry out a really large attack wave against customers over a period of about 2 hours, sending out tens or hundreds of thousands of emails. Usually these scripts just act as loaders for additional malware. For example, in this case, it's not clicking. Okay, cool. So in this case, for example, it just downloads a payload from the web and then executes it. So it's an executable payload, a PE file, and then it loads ransomware onto the machine, encrypts all the user's files, had it been successful. Okay, so this is a quick look of how scripts are used in persistence. Cofter is one of the more famous malware families which use malicious scripts for persistence upon infecting a machine. So it actually doesn't use scripts to, apologies. Yeah, it's coming back here. Okay, sorry about that. Okay, yeah, so Cofter does not use scripts as its initial infection vector, so it's not true fileless malware, I wouldn't say. However, once it infects the machine, it sets up its malicious JavaScript content to run in a registry key. So in here, you'll see an it sets up an auto-run registry key, which actually invokes mshta.exe and then passes the malicious script content on the command line to mshta. So in this way, there's actually no malicious file on disk in this attack pattern. Scripts are really easy for the attackers to obfuscate. They've got many different ways to pack their scripts. There's pretty much an infinite number of ways to pack it. Here are a few examples of what some of the packing methods look like. But it's really challenging as a security researcher, as an AV product, to protect all of our customers from these attacks, because they go out of their way to test their new packer algorithm against the AV products before carrying out their attack campaign. And us, in order to respond to it as a traditional AV product, normally what a researcher would do would be they'd collect a few emails, they would collect a few of these attacks from the same attack campaign, and they would write a regex-like expression, which would be able to detect all variants of the same attack wave. Then we'd have to take that signature, go through false positive testing, make sure we're not going to have a huge false positive. Then we deploy it as a signature to our customers. Meanwhile, their attack waves work on a much faster cadence. So they would begin the email campaign, and their attack campaign might only go for a 1 hour period where they send out 100,000 emails attacking 100,000 different customers, and there really isn't time for a human to be involved or for a signature release process to be able to actually protect all these customers from these attacks. So really, machine learning is needed for proactive response, to proactive protection against these type of attacks. And in Windows 10, we introduced a new feature called AMSI, which is available to all the AV security products that are out there to help combat the malicious script problem. Well, it's used in part to protect against a malicious script problem. So AMSI is a standardized anti-malware scanning interface. It allows any app developer, you don't have to necessarily be a Microsoft app developer, to create calls into the default installed AV product on the computer. So this doesn't have to be Windows Defender AV. This could be Kaspersky or Symantec as the AV product which is installed on Windows, and then they'll be the handler of the AMSI calls. Now, any app developer can use this API to call for scanning of content on your machine. But in Windows 10, we've introduced integrations of AMSI calls into the Windows 10 scripting engines to help combat these malicious scripts. So you can learn more. We've got this all publicly documented, so you can go have a look at how to create calls or how to handle calls into AMSI. So at the Windows 10 launch, we announced PowerShell integrations, Visual Basic Script, JScript, and UAC integrations. So these integrations, so PowerShell, first of all, is open source. You can actually go check out all the source code on GitHub, but it creates an AMSI call every time PowerShell code is compiled. So at compile time of PowerShell code, it creates a call into the AMSI product with the whole PowerShell content. So this will allow any dynamically loaded PowerShell content to be passed to the AV product to scan every time you load PowerShell on your computer, any new PowerShell script content. So if an attacker uses the command line to pass in a huge PowerShell script encoded by base64 on the command line, that'll be unpacked out of base64, and then that'll be handed into the AV product to scan before that PowerShell executes. So there's similar integrations for VB script and JavaScript, where any dynamically loading new JavaScript code, and also prior to executing any JavaScript or Visual Basic script code, it will create calls into the AV product to scan. So this includes all these AMSI integrations are in cscript.exe, wscript, mshta.exe, or anything that uses the javascript.dll or vbscript.dll. And same for PowerShell, any way that PowerShell is used. Now, what we're going to be more talking about today is in the Windows 10 Fall Creators Update, we actually introduced behavior instrumentation of these scripting engines. So not only do we get the dynamic script contents during execution, we actually get the actual behavior of the scripts during execution being passed into the AV product installed. So this looks more like behavior logs, like you can see here, which is actually the behavior of the script, not the script content. And we have a similar behavior instrumentation now with Office 365. So if a customer falls victim to a macro-enabled attack, they agree to enable macros, macros are running. Now it's actually logging the behavior of that macro content during execution, and that's going to be passed to the AV products installed on the PC as well to protect the customer. So lots of security products do support scanning of AMSI content, at least in some limited way. Here's a list of some of the AV products that do support handling of AMSI calls, at least that we could find using public sources. Okay, so now we're going to talk a little bit more about this AMSI behavior logs, because that's key to the ML topic here. Here's an example of what malicious malicious JavaScript code is in this case, and this is the corresponding malicious behavior log. So here you'll see it downloads the payload, downloads a PE file payload from the web, and writes it to disk. And then if you look at the fourth behavior log from the bottom, it's actually changing the file format of that downloaded file to have a PE file header. So, and then they're hosting it with rundll32.exe at the bottom there. So whenever the behavior instrumentation hits execute or run type command, it pauses the execution of the script content, and then it hands in the whole behavior log to the AMSI interface to scan the contents. And if the antivirus product decides to block it, it's actually going to abort execution of the script, and the execute command is not going to be allowed to be completed. So here's another quick example. This is a Visual Basic script.encode command, and when this is executed, you can see it didn't provide much meaningful behavior. There was no run or execute command, so there'll be no AMSI behavior call created to the AMSI engine. However, the dynamic content calls would still have been created, but not the behavior log. If the run command is reached multiple times in a script, it's going to create multiple calls to the AMSI engine with more and more behavior available for use in the classification. So now, before we, now to get into the machine learning side of things, I first need to describe a little bit about how our main machine learning application works in Windows Defender. The bulk of our machine learning protection exists in the cloud. So when a client here on the left initiates a scan against file or a behavior, we actually ask the cloud for a machine learning decision. So we actually don't want to send up the whole AMSI behavior log to the cloud. Instead, we describe a featureization of the content up to the cloud. This includes the emulated behavior, it includes the fuzzy hashes of the content, and it also includes specialized machine learning vectors that we've deployed for each one of the scenarios. So then we have these features get sent up to the cloud, and then we have about 40 real-time classifiers that run on clusters of servers located around the world. And all these classification stores get combined with ensembles, and we run decider rules and ranking logic in the cloud in real time, combining with offline deep learning models and many other data sources around Microsoft to come up with a decision in real time. So the problem is it's too costly to ask our cloud for every encounter that our customer encounters. So instead what we do is we also deploy lightweight machine learning models in the client, which we actually pair with the models that we deploy in the cloud. So we actually train a lighter weight version of the model, which is optimized for performance and low overhead on the customer's machine to do classification client side. And only if it evaluates positive will it then build the full feature set describing the content, send it up the cloud for the full classification. So first we're going to talk about how we built the feature vector to describe the content, the purpose-built machine learning feature vector. So this is the part of the features which are sent up to the cloud, which is the machine learning feature vector. So we detonated in sandbox environments a large collection of known clean and malicious scripts while recording AMSI behavior logs, and we use that for the features to base our feature selection of what we're going to deploy to the client. So first off, of course, we include as features all the COM function names which are referenced. In this case, we had 6 COM objects which are referenced, and similar for all the COM function names. So we had 193 COM objects referenced. And then in order to describe the function arguments in the behavior logs, we do character n-gram description of the content. So this is, we take like character 4 grams, 5 grams, 6 grams, 8 grams, 12 grams, and we consider all those as potential feature candidates. And I'll show you what these features look like in a minute. In the character n-grams of the function arguments explodes into a very large number of potential features, too many for us to deploy to the client. So instead what we do is we do a down selection based process to choose which of those character n-grams are best to deploy to the client to separate clean from malicious content. So in our case, we use our learner-based down selection, which uses a linear SDCA classifier, and then we do the down selection through L1 feature regularization and feature trimming. Basically, we train a machine learning model and then let it sort out which are the most important character n-grams to deploy to the client, and we select the most important features. You can think of it like that. In this case, we actually only deployed 300 final n-gram features, so small little character tokens, you can imagine, sequences of characters, to the customer to describe the function arguments. As a quick side note, for those of you more familiar with these processes, we did compare the learner-based down selection versus mutual information down selection, and we found that the learner-based produced features that resulted in higher quality models. So now this is the more fun part. This is actually, I'm going to show you how the features actually describe an example malicious script content here. So first off, we would describe all the COM function arguments which are referenced by the script. In this case, we've got about 5 of them here. And then we'd be describing all the COM functions which are referenced within the script, highlighted, I think, blue there. And then this is actually, all these red parts are actually what all of the final 300 character n-grams that we deployed to the client describes. So it's a pretty reasonable description of a lot of the features within this behavior log. So this is just the machine learning feature vectors that we deployed specialized to this scenario. This is added to other features such as the fuzzy hashes and similar. So another problem is another problem with it is that the sandbox-based logs don't really represent the behavior of these scripts in the wild on customers' machines when they're infected. So what we do is we actually just use the sandbox logs to deploy the specialized features to the machine. And then what we actually train the model is based on in the wild customer encounters with known good scripts and known malicious scripts. Because there's a lot of enterprises out there which use all customized enterprise scripts to their enterprises. And there's, of course, we don't have those files to make sure that we avoid them as false positives. So instead what we do is we actually train on all of our customer in the wild encounters with all of these AMSI behaviors. So the client-side model is focused on being highly performant. We've got a highly performant engine for running logistic regression models. So it's optimized towards low memory usage as well as low CPU costs when scanning content. And then that's what's paired with our heavier model in the cloud. The heavier model, in the real-time models which we deploy in the cloud can be a lot heavier. They can use a lot more memory. They can use many more features. They can use a lot more computation costs to make the classification. But it still needs to be scalable because we handle about 4 billion queries a day in the cloud. So we did some sweeping of the different learners in application to this problem. We found that the linear-based models performed the worst in this case. We did try a fully connected neural network. It's not exactly a deep learning approach, but I did outperform the linear models by a little bit. However, we found that the tree ensemble models perform the best overall. The reason why we think that the tree ensembles perform the best is that it's able to model feature interactions. For example, it's able to model a different malicious or clean weight depending on whether it has a specific function argument n-gram match with a specific COM object match within the log versus a different COM object match within the log, because it can actually mean very different things, and a tree model is able to better model those feature interactions. So in our case, we chose LightGBM. So LightGBM is a tree ensemble. It's just 100 trees to come up with the classification. Nothing too fancy about it. So here's a quick look at the different feature contributions to get an idea of what features were most important to the model making a decision. So of course, including all features performed the best. We found after that the specific targeted machine learning feature vector that we had deployed was the most important, were the most important features to making the decision. After that, the fuzzy hashes had a very significant role in the classification. And finally, partial hashes, which is like partial hashes of the behavior content, did not perform well in the classification. Okay, so in a quick summary, Windows 10 has script integrations for a lot of the different script types. It has dynamic script content scans, which is script content scans before execution, but also during execution of scripts when they try to load further script content. It includes the dynamic behavior calls scans. So here's a quick summary. So PowerShell has all the dynamic script content scans. And then for VBScript and JavaScript, we have both the dynamic script content scans, which is the script content itself, and we have the behavior scans for those. When it comes to Office VBA macros, that was the feature that we announced very recently, I think about 2 months ago. We just have the behavior-based AMSI calls. However, AV engines are already scanning the macro content prior to execution, so there isn't really a need for the dynamic script content in the case of Office macros. Security vendors can effectively use machine learning against these AMSI content to create classification. On the Windows Defender AV side, how we do it is we do paired client machine learning models, which are performance optimized, with a heavier cloud machine learning models. The purpose-built machine learning vectors greatly improve the quality of the results. So I'd recommend if you're to approach a similar problem that you'd want to use purpose-built machine learning vectors. We also have built machine learning models specific to each one of those scenarios, each one of those AMSI scenarios. So we cover the VBA behavior, PowerShell, JavaScript, and VB script dynamics contents as well, where we did a very similar feature deployment process to decide which are the most important character engrams to deploy to describe each one of those content type scans. And Windows Defender AV, at least from the script protection scenario, is just part of our overall protection story. There's a lot of other features within Windows Defender AV which can entirely stop a lot of these script-based attacks. Like there's ASR rules, attack surface reductions, where you can like disallow any macro content from doing an execution at all. You can outright entirely stop entire attack patterns. Like I know our Office 365 team has an entire machine learning team dedicated to scanning and detonating scripts before they arrive in your email inbox. So we're just part of the picture on the AV side. We're hiring a lot in Windows Defender AV, so shameless plug if anyone's interested. We've got lots of reverse engineering, PM, software development positions. They're mostly based in Redmond. Although I'm from Vancouver myself, most of our team is based in Redmond. Okay, cool, thank you. Any questions?
That was interesting.
Cool, yeah. Thank you.
So we have a second microphone, and if you got a question, I'll just pass it over to you.
Okay.
Is that stuff turned on by default, or is there something you got to do to make it happen?
So it depends on what your operating system is. Like there are different minimum requirements, like Windows 10 builds required to be enabled. For Office 365 also has, I think it's like the feature we announced about 2 months ago, that AMSI integration requires a minimum Office 365 version, which I think most people don't have yet. Is that what you're asking for?
Yeah.
Cool.
We're going to Windows 10 now, and I'm wondering, like, so then with Windows AV, automatically have all these features built in.
Yes, it does. Yes, Windows Defender AV. Yep.
So I had a question on, you were saying that the on-client models had a curated set of rules that they're looking at that then basically that's curating what the data is going up. So I'm wondering, how do you make sure that your rules aren't self-reinforcing themselves and your data set is getting too narrow?
Yeah, that's definitely a good question. So as I understand what you're saying is, how come we know that the client machine learning model is just bringing up exactly what our cloud model already detects? How do we deal with all the unknown files that are out there? How do we know if they're being caught with a client classifier or not? So, yeah, and how do we prevent that from happening? So, although I cut it out of the one slide, we actually have more to it than that, than just the client machine learning model bringing up queries. I actually included it in this picture. Oh, come on. Okay, so we have more than just the client machine learning models bringing up queries to our cloud. We have, whenever it's a high risk, low frequency event, we ask the cloud for decisions. And also we have random sampling that occurs in the client, where we get random sampling of customer encounters with files. So we actually are able to train and discover stuff that we're not detecting when it's missed by the client classifier, if that makes sense. Yeah.
Why do you think AMSI is not adopted more widely by the third-party AV vendors?
That's a really good question. I think a lot of the AV vendors are trying to compare the value versus the engineering to support the feature. It's more than just adding AMSI integration to your AV product. You actually need to write. You don't have to use machine learning protection like we have. It allows you antivirus researchers on those companies to actually write signatures, and they would like signatures. Like for example, it's creating a suspicious exe file in temp, and then running it, and then that would outright block that. So the traditional AV signature way of writing antivirus signatures against a behavior can still apply to this. But if they add support for AMSI, they also need to invest researcher time to write signatures to act against it. And building a machine learning scenario like this against behavior as we found out going through this project, is a very challenging experience. Is a very challenging from like controlling the amount of false positives and deploying it as a feature end to end. It takes a significant amount of work on research side, I would say especially. So there's a lot of support cost to it, and comparing that to the value, I think some of the AV products may have decided that maybe they don't want to invest in it. I don't know. I'm hearing more AV products are investing in it, but I really doubt whether they're actually investing the research or time to feature properly, though.
Sorry, I have a question. So the data that's generated from this seems to be like really valuable, especially I'm kind of thinking of it as from an incident response perspective. And even like maybe there's something that's run from the AMSI engine and it doesn't get flagged as malicious, but my question is, are there logs for this that's accessible, or is it down to the AV provider to create these logs?
That's a really good question. I have heard reference to, I think, the PowerShell script execution logs, I think, being recorded with Windows event telemetry. So like, I think you can set up Windows event forwarding of some of these events, like not through the AV product. And I think they are logged as ETW events, Windows ETW events, so you can add hooks to look at that. But I had intended for this presentation to do a little bit more research on how you as an enterprise can get those logs forwarded, but I wasn't able to get to it, unfortunately. But I know there are enterprises, like including, I think, Microsoft as an enterprise, where we are especially forwarding the PowerShell execution events. And that's a really good use case as AMSI. But I'm sorry, I don't have a lot of insight on that side. Hey, question there and there. Oh, yeah, perfect.
Thank you. So if the Ask the Cloud piece is triggered, what is the average response time from Windows Defender Cloud? And then what are the common use cases that you see for the implementation of the AMSI in the applications? Like?
Yeah, so our round trip response time, I would estimate, is around between 100 and 200 milliseconds. It depends on which country you reside in. The second question was, what are some of the example use cases of like enterprises of these script types? Yeah, you'd be surprised. Like enterprises use, like even outside of like PowerShell is like ridiculous amounts of enterprise use. But even when you look at Visual Basic Script and JavaScript being executed on these machines, it is used really widely in enterprises, believe it or not. It really surprises me. There's a lot of custom enterprise scripts. So yeah, enterprises use like those HTML applications, believe it or not, for like, I've seen it for like auto server deployments and things like that. There's lots of really interesting, legitimate use cases of those script types I've found. Yeah.
You mentioned a random sampling of binary assets as well as an upload of events, of assets that represent a low frequency but high probability of being actually malicious. Is there any way of being able to opt out of that uploading?
Sorry, could you repeat
the binary? You mentioned random uploading of binary assets.
Oh no, that's not random binary uploading.
Okay.
So that's just the random feature description being sent out.
Oh, I see. Just
Yeah.
if it was...
not random file submission.
Understood.
Yeah.
Okay, good stuff. Is there any file submission at all?
So not in the AMSI path, like these buffers, we don't have a way to request them. It's complicated, yeah.
I got two questions. Is Windows Defender still using the Intel Threat Defender technology?
Sorry, the
Intel TIA. It's a
Okay.
Intel Threat Detection technology.
I think I've heard reference to it, but I don't know anything about it. Sorry.
No, it is not using it because Defender
Yeah.
used to.
Okay.
And then the other question is AMSI going to be coming to server technologies, the server OSs?
Yes, so I think Windows Defender AV does support Windows Server SKUs. I think I think that started within the last year or two. So there is official support for them.
All right.
Yep.
Any further questions?
Oh, one more question. Okay, yeah.
All right, so you said 200 milliseconds return time between lookup for features and then decision of whether it's bad or not.
Yep.
During that time, are you actually halting execution of that script and waiting for that and then executing it? Or
Yeah,
are you just letting it run and then after the fact going, oh, that was bad?
We're able to control that depending on how confident we are on the ask to the cloud.
Okay.
So we are trying to hold it as long as we can to wait for that decision when we decide to ask the cloud. But it depends on what the reason we ask the cloud.
Right.
Okay, yeah, thank you. I think that's everything. Cool, yeah, thank you.
Thanks, Jeff. And lunch is coming up. I guess we're a little early for that break. Thank you.
Testing, testing. Okay. So that would be the one that you can run. Do you want to hold on to it, or we can sit it on your chair?
No problem. Yeah, no worries. Got it, man.
Testing, testing. I just want to make sure you can connect your laptop and everything's good to go. So definitely set, and then let me know so I can know where do I need to run and grab a cable or something.
Okay, so connect to that?
Yep, HDMI, will that work?
Should be, if nobody's stolen my adapters. There's a million adapters.
You are prepared. Awesome.
Yeah, they're like
Some
pens
speed.
though. They seem to go walkabouts a lot.
Yeah, yeah.
Yeah, it's looking a bit light.
Yes, that's me. Okay. Yeah, just want to find you. Yes. Oh, okay. I will run up
Yeah, I
and see.
don't have a
You don't have a.
display port to HDMI.
Okay. So I
Sorry.
will see if it's it. So that sounds like we need two then. I will run up and see if they're in.
Just remember where I normally present, they have one for me. So I think I actually left mine at Code Core, so I don't need one anymore. And do you guys have a clicker or I use my own?
I think everything's
Okay.
test before.
Two, that's always better than one.
ADA, so I've got that one here.
Like that, except for HDMI.
Okay, hold on. I will run back. So this one almost worked. Okay, so.
You've got two there. If I could read them, we'd be perfect. I'm a big one for talking too long, so I'm always like, it's okay. Trying to time it. Don't worry, I'll handle that for you. Yeah, you'll be like 5 minutes left, and I'll be like, I've got half an hour to talk. If you get some time, run a Q&A. Yeah. Perfect.
Yeah?
As long as it's not an Apple one. Oh no, it looks generic.
No idea.
I know that
But I have
something
other ones
weird.
if that one causes you any problems.
There's something weird with Apple ones.
Oh, anything Apple, if you can do anything.
Even
Yeah.
even if it fits, it doesn't still. So do we need to turn this on, or I just go into projector mode, or?
Should be on the CD projector. Oh, okay. Panel.
Yes.
We're just trying to turn on the projector. Yeah, it should be one of these, but I'm not as familiar with the projector, so. Okay. All right, thank you. Actually, I wonder if I can just try. It actually looks like it's on because the light is on. Maybe one of these, maybe the port just isn't working. I want to try another one just in case.
It just doesn't seem to be glowing.
Okay, perfect. Because it looks like it's on, but not getting the video. So maybe it's the adapter. We might as well.
Did you press on? Because it could be just a standby light.
Oh, you think so? Okay. That would be very
For
silly.
the first second, it went blank, and I'm like, okay, now it's off. But yeah, now we've got two lights. So I would guess that's more good.
It's okay. It's still not at 150, so we're perfect.
It's old school.
Hey, turn it on.
We're so
That
used
is
to
very
things being.
bright, though.
Yeah.
Okay, perfect. So I will take all these back. We should be good.
That's your makeup. Oh, this one?
You can just grab it.
Yeah, and it should be on, so let us know if it's just sticky. Sorry.
Hi, everyone. Welcome to BSides Vancouver 2019. Today's topic is how to secure serverless by Matt Caroline. Thanks.
Do you want to wait till 1/4 past, or sorry? Do you want to wait till 1/4 past because people might be still coming in, or you can just start? Okay, cool. Sweet. Okay, hey there everyone. Just while people are making their way in and out, just for a show of hands, because I like to just gauge and talk to what you guys want to hear. Who's already using serverless today? Okay, and who's just heard the buzzword and interested about it? And who's not doing any development on serverless but is worried about securing it? Like, it's sort of one of those things where, hey, yeah, okay, we've heard the buzz, it doesn't need any security, doesn't need any patching, that sort of thing, but you don't believe it? Okay, cool. So yeah, my name's Matt Caroline. Been doing IT, I don't know, about 15, 20 years. Last 10 years I've been in the cloud space, so working on AWS and Azure. And yeah, serverless is something, I don't know, working, especially being in the cloud space for the last 10 years, I've heard a lot of buzzwords that I've been like, I've been doing that for a long time. When did this term suddenly present itself. So serverless is one of those things where kind of, in my mind, a lot of the things that were great about cloud when it first came out were sort of on the serverless side. And then we all started saying, hey, but I'm not used to this. Give me VMs and things that I can almost hug. And so they started bringing out block storage and VMs and things like that that we're more used to, and I don't know, gives us a bit of job security because we can now patch them, and like we might not be doing firmware updates anymore, but we like keeping those boring tasks on hand, sort of thing. But I do feel like that evolution is happening. In my mind, it's sort of we've got the old school servers. It went to VMs. Containers has come along, taking a lot more off our plate. But ultimately, where we really want to be, well, in my mind anyway, is serverless and SaaS and those sort of pieces where we can actually concentrate on the end users, the experience, and things like that. But in saying that, there's still a lot to look after. And in breaking up all these things into a lot of different buckets, there's a lot of security pieces where we can open up the gaps, where we're not just looking after one rack anymore or one rack on each side of the continent. We've now got lots of little pieces all over the place in this software-defined world. So I wanted to begin with just talking about what is serverless, because really, if we don't understand what we're actually trying to keep secure, it's hard to really effectively secure that environment. If we take on what we've been doing previously and apply that to the new world, you'll have a lot of apps, tools and things that just will give you false positive readings. They might say, hey, yeah, you're all patched because you don't actually need to worry about patching. Or there might be other pieces that you didn't worry about previously because it wasn't your responsibility, but now they've come into your world. I see that a lot with government especially, where in government it's a lot harder to shift the mindset of, hey, I'm just doing databases or I'm just doing the storage bit and this is my world. Particularly with serverless, it tends to bring in everybody from all the other facets to bring around. So really, serverless is about not having to, if everybody here knows the traditional stack where we've got the hardware at the bottom, then we've got the operating system, the middleware, and then your data. Really, most of that stack, if we're running it in the cloud, where a lot of that is looked after for you by the cloud provider. Now, you can run serverless on-premise, in which case, yeah, you still do have to look after the hardware it's running on, but that's more of the main thing that most people are running out there is on the cloud. So the reason that you might want to run serverless on-premise most of the time is for testing, to have it close to you, test things out, not have to worry about redeployment and bug fixing that way, test it on-premise, and then apply that up to the cloud. So in your testing world, you might be a bit more relaxed on looking after pieces there, although it's still very important to have some pieces which we'll go through in a bit. So if we keep with serverless running on the cloud, really all you're having to look after basically is your code. You're looking after your code, making sure you know no vulnerabilities there, and we're trying to really make sure we keep things as simple as possible for yourselves while giving the cloud provider all that responsibility that we used to look after, such as the operating system, the middleware, patches, security, those sort of things. So the benefits, so why would we do that? As I touched on, just that focus, being able to not have to worry about all those tasks that have kind of hindered things. Also, the other negative to having patches and security pieces always having to worry about with VMs and operating systems and firmware updates and things is your code can sometimes get impacted by that. Whereas when we've got a cloud provider looking after all that for us, they're keeping everything very consistent so that we shouldn't have to worry about the impact of what they're doing in the back end to us with our code. So we can then focus on the code and then also scale. So the idea of traditionally we're running VMs, we might be running clusters. If we're doing containers, we've got swarms of containers to look after load coming in. That sort of scale is all looked after by the cloud provider for you. So you don't have to worry about that scale. You don't have to worry about redesigning your code for the traffic coming through, those sort of pieces. And again, I'm assuming here, like when I'm talking about if we were to do an application from end to end serverless. I must say also, a lot of the times when I'm using serverless, it's for one piece of a job. I come from a background of 20 years ago in the developer space, got into the sysadmin space, and more helping developers get their code working, the orchestration, those sort of pieces. These days, I'm finding myself back into that developer space because everything's code now again. But yeah, doing that scale there, and then flowing on from just talking about so how do they bill you in the cloud for pieces where you've just got code. You don't have to worry about compute, storage, those sort of pieces. It's just your code that's going up there. So what they do is they'll bill you for, a lot of the times it'll be for while it's being executed. So while that code is being executed up there. So I'll talk about a few best practices around that. There are and when we're talking generally about best practices, there are exceptions to the rule where we might say, hey, I need, because of my usage, my use case, I need it this certain way. Definitely when we're talking about serverless, it's more, the security is more around keeping things in order rather than, hey, this is the only way to do it and you're silly if you don't do it this way. So if we talk about AWS specifically, for a serverless, I just threw a bunch of icons up here. There's a lot more that Amazon classifies sort of in that serverless realm. Now, I'll run through a heap of them. It's kind of debatable, sort of like the word cloud has become now, and everybody uses the word cloud. I hate the word cloud now. And there's a lot of everything's converged. That word seems to be overdone. And I'm starting to see serverless. Now everybody's like, well, isn't that serverless? What's the definition of serverless? And we start getting pretty long lists where we basically end up saying, hey, if it's not a VM and it's not attached storage, then is it serverless? But really, the real crux of it is Lambda on AWS. So when Lambda was released a few years ago, my mind just went, great. I've got all these little Linux boxes doing little cron jobs, and I hate the fact that I'm paying like $14 a month or something just for this server to sit there idly by just to collect some logs or to reset a service that I know fails every now and again because I'm a lazy coder and I don't want to actually find the actual problem. So Lambda I was using, but they didn't bring out scheduling at first, and a lot of my stuff used scheduler. Now they got scheduler, so we could do little codes that are scheduled. And we also got other pieces that'll flow on from this that it's all connected to. And a lot of these things are serverless. Some things also not serverless. I end up a lot of the time saying, hey, I'll start off with a monolithic legacy sort of architecture because a lot of my clients are moving from that enterprise space over to the cloud. And piece by piece, we'll look at pieces and we'll say, hey, you know what? Before, we were putting everything on one server. Now let's break them all apart, all these little services. So something that you might use Lambda for today, if you're not using serverless, it might be something that is just a routine job. Maybe it's a command line or a cron job or something like that that you have running in the background that you just happen to have maybe it's your domain server or something else that you've got a bit of compute free and you've said, okay, you know what, I'm not going to use my rack space or number of VMs just to have this one simple task. I'm just going to have it run on this existing server. So those sort of things we can break out on their own and have running as just some code that's maybe scheduled or triggered by other events, and break these things out. The other advantage to doing that is you've now got less dependencies. If previously you were running these little tasks, sort of piggybacking off this greater, more important server, say it was your domain server or your email server or something, and that broke, then that could also stop that small function that you have as well from working in the first place. So Lambda is really, so then we've got a whole heap of other services. We've got Lambda Edge, which is really looking at your CDN, your CloudFront on AWS, and getting your serverless code executing closer to the end user. Fargate, S3 storage is another one. Now, why I'm putting these in bold is to kind of connect a simple story together. S3 storage is, like I said, a long time ago before I even really heard the term serverless thrown out there. There was this S3 storage from Amazon. It's object storage. You don't have to worry about any servers. It scales for you automatically. Just create a bucket, start throwing your files in there. So in effect, that's serverless there. You got their elastic file system to look after your block storage as well for you, DynamoDB, serverless like database there. That Amazon's own Aurora has now gone serverless about 6 months ago, so you've got an option there for them to give you the same benefits of their Aurora on RDS, but with the advantages of serverless. API gateway is something that I'll probably touch on a little bit later on authentication. And Amazon SNS, one of the early services on AWS to give you notifications about pieces that are happening. So you could use that sort of as a trigger for serverless. SQS with their queue service, step functions, which are kind of related to earlier on Lambda, to have things triggering. Kinesis and Athena around just your data, big data, moving that data, changing it into the right format that you want. So there's probably a lot of other services on Amazon that you could, there's over 100 services there running on Amazon. But a lot of these, I find really good stories of interconnecting these pieces together. So the ones that are done in bold, Lambda, S3, and SNS. You could have your Lambda taking some input, storing it in S3, and triggering a notification for you once that's arrived in there. Maybe it's resizing an image or something like that. But as you can see, it's quite a long list. And I've just talked briefly just then about a simple resizing of an image, and it took 3 different services. So how do you keep, like right there, there's a security vulnerability of having to keep an eye on that sort of amount of pieces, whereas before you probably have one VM, it was a minor job within the VM, probably part of an application, and it sent you an alert that the developers of that application did for you. If we look at Azure, try to illustrate it for a different story here. Really, we're talking about, like, we've got a trigger, we've got the serverless piece here. So Azure Functions, similar to AWS's Lambda. So we'd have a trigger here. Something comes into Event Hub, gets triggered, triggers your code to run off, and then we can be messaged about it, stored in a database or a object storage there. Now, all these things lead us to best practices around security. So really, I painted the picture of all the options there around serverless. Obviously, a lot more, but really leads on to several problems that many people overlook out there. So authentication's one of them. So if we look at the actual code side of your code there, now you might have multiple devices. You might have mobile devices. You might have desktop like Windows and Linux accessing. You might have websites accessing. you're probably going to have a separate function or a code set for each of those to display things in a different way, different use, because the way people use or want functions out of an application is different on each of those devices. So because of that, you're going to want to make sure that you're keeping things in check, things are going to the right areas, and we don't have any holes in there. Now, you could have everything going through directly to your code. You could use different authentication engines. You could use like Azure AD, or you could use IAM accounts. But really, the way I direct people if they're doing coding, and this is, like I said, just an option, is the API gateway. So if you're using an API gateway within Azure, AWS, or any other cloud providers out there, this will really help you manage the direction and path of all these commands that are coming through to your code, but also make sure of the authentication at the same time at that sort of central point. Another piece is making sure that you're actually, for the end users, looking after that authentication as well, and your admins and other access areas. So if we're dividing up groups, who's got access to what databases have got access to which other steps in your functions. So really looking at making sure, and this is a practice that's not just for serverless, we talk about it all the time in other areas, but particularly here we want to have least privilege access to make sure that nothing slips through the cracks here, because we've got so many different pieces running around. Cloud controls. So as we talked about earlier, where we've got a lot of the stack being looked after by the cloud provider, what I direct a lot of people to do is start off with using the native cloud tools within Azure and AWS to manage their serverless environments. So managing, looking visibility and management and controls for serverless environments is still relatively new. And there are a lot of third-party applications that do a really good job, much better than the cloud providers themselves. But you may not need that level. So I always direct to start off with the cloud providers themselves, because they're going to have better integration a lot of the times. And a lot of the times it's free integration that you're getting anyway. You're not going to have other pieces tied in that could fail, that could have issues. So there's a lot less that can go wrong. Serverless does become, it's great. I use it, like I said, for little pieces, but when you're trying to do a whole solution with serverless in mind, it can become a bit of a mess. So the less pieces that you have in play, the better. And if you're using a cloud provider, their own native pieces, then you can just, a lot of the times, those same tools to monitor, you're also using it for other pieces that might not be part of that serverless application. So less tools to learn as well there. But obviously there are times where you need to, maybe you've got PCI compliance, or you've got health information, PI data, that you need to have stronger controls than what the native cloud providers provide, in which case, yeah, look at third party then. But I wouldn't jump straight into the third party bit. I'd start off with the cloud native pieces. So visibility that I touched on before, that's probably the biggest threat I see to serverless out there, is that sort of documentation is one piece, but what if you've got several people doing different pieces, you've got your development lifecycle happening, and people just aren't documenting. In reality, the amount of companies that I go to and I say, hey, can you just give me a Visio diagram or something where, give me a lucid charts of just your VMs, or just give me a number. How many VMs do you got? And I'll get oh yeah, we got 300. And then we find out later it was actually 900. And you're going, how could you make that sort of big mistake? They're VMs. You could just go into VMware and it'll pump out a report and tell you. But it's because people just lose track. It was probably 300 2 years ago when they last looked at it. They've never really looked at it since, because they don't have that sort of automation and management in mind. So with serverless, it's going to get even worse than that, because you're not going to have one VM that looks after multiple functions within it. You're going to have multiple pieces all running around. And that visibility and documentation and planning also can lead to like not just better efficiencies in your code, but the security and making sure that we're not opening anything up there. And I see it all the time, like the S3 buckets in AWS. I think a lot of people are kind of dismayed that health organizations and that are just opening up publicly their buckets. But it's probably due to, well, laziness, but laziness due to not documenting things. And they're probably trying to work out, I would hope that they at least attempted to do it securely and open up a path, but they just couldn't work out who needed access to what, or what subnets had been created for where or what IAM. So they've got no organization or visibility on what they have, so therefore they just opened it up public and went, hey, that works. And never expected someone to do a scan on everything public on S3. So visibility, I think, is more critical than ever with serverless, because you've got a lot of pieces in play. And then the dev lifecycle. So throughout the lifecycle of your development on serverless, just keeping security in mind. So I was talking earlier about a lot of coders out there, when they're doing serverless, they're probably going to bring their serverless code onto their own personal laptop. And we can't stop this as admins and that. Like, we see it all the time, people out there, like, they've got file storage and they go off and use Dropbox and they go share files and things like that way. I mean, you can control it, but the more that we put up barriers around things, the more people find ways around. I mean, I used to say years ago, when Facebook and that was becoming something that business owners were like, everybody's just doing Facebook, nobody's doing any work, they're just on eBay all day, let's just block it all. What we found, when they blocked it all, they just tethered off their phone, they still wasted their time, everybody started using their phones. But what was more effective was documenting what's allowed, what's not. And I do a report for my clients where we do a shame sort of thing, where we'd say, hey, look, this is how many people were on Facebook this week, how much percentage of the day they were on each, and we know who you are. We're just going to put this on the kitchen fridge and just kind of shame people into going, you know, like, because there's legitimate reasons. People use social media and that for personal, like within work. You don't want to go into a bunker for 8 hours and come out the other end without any communication to the world. But there's a balance. And so that's kind of it here. Like, coders are going to be lazy and they're just wanting results. And security's boring. It's going to hold things up and it's going to get in the way. So just having those policies in place, having it part of the dev lifecycle before it can move from that piece, sure. Let them have their test environment on their own laptop, do the code, be lazy, but before it can even leave there, we've now got security steps that we've got to make sure are ingrained in there. You've now tested it, you've shortcutted things, you've got it, but we've got policies and security practices within this whole life cycle. Because otherwise what's going to happen is you're going to go through like testing, QA and all that, get to production, and then the security team's going to be like, whoa, hang on, nah, this isn't going to work. And everybody's going to get upset at each other because all of a sudden the code now won't work the way the security people are forcing it to go. So having security in mind throughout that life cycle. And then that kind of flows on to I think this is my last point around general best practices, which is the dependencies and third parties. So if we've got that dev life cycle happening with security in mind at each step, you're going to pick up on pieces where you're going to have dependencies to bits that aren't serverless or are outside of your environment. Or it might be a third-party SaaS application that you're pulling in, or maybe you're passing emails through a third-party service, something like that. But making sure that that is in that dev lifecycle, making sure that security is in mind for them. You don't just pass it off to them and say it's their responsibility. Is the tunnel between secure? Are we passing it off in the most secure method? Are the third parties, it might not even be as simple as them being some sort of SaaS conduit. It could be a third-party company that's got access into your environment, access to your data that goes afterwards. I mean, I got told the other day, it was 5 years ago. I find it hard that it was that long ago, but when Target, all the credit card information got taken from Target years ago, that was a third party. It was not actually Target that let that slip. It was a third party that was handling their credit card information, and they just didn't do due diligence on how they were handling that information. So keeping that security in mind all the way past. And I kind of see the third parties or other dependencies as another piece of that serverless bit. Like I was talking about earlier, we got all these little pieces of the puzzle to make up like this serverless solution. And even though the cloud providers are looking after the whole stack, and even though third parties could be looking after a lot for you, you still got to make sure that the traffic between, access for them is least privileged, all those sort of pieces sort of tying together. Okay, so when we're talking about AWS, it really is very, very similar topic to the other cloud providers, and we've gone through a lot of the pieces there. If we went back to the different services we have there, there's a lot of things to be mindful of, a lot of different options. Actually, I'm just realizing API Gateway, which I talked about earlier, was one of the points that I was going to make at this point. But yeah, you've got a lot of serverless pieces in play, and then for Azure, I think actually I'll just skip over these two bits. I'm finding that I've actually talked about a lot of the points that were for them, kind of blended them in previous. So on that, in wrap up, I think the biggest important thing around serverless, like I hinted at earlier, is not your traditional security methods of having, you're still going to have your firewalls and your network structure still properly in place, but it's more around having that visibility, I think, kind of ties everything together. If you've got that visibility and control, then all those other best practice pieces that I was talking about, the authentication is going to make sense. You've documented everything. You've got that visibility. You've got that control happening. And all the other pieces of the pie sort of blend together and pull it in. So it doesn't matter if you've got many different services all blended to come to one solution that aren't in one VM or cluster together as one service. You can blend this. You can have databases as a service. You can have your code as a service. You can have your front-end CDN as a service. But as long as that's all visibility and control in place, whether you're using the cloud provider or third parties or your own documentation, your own lifecycle management, that's how you're going to be effective in seeing those vulnerabilities come in the first place. So on that, does anybody have any questions? Yes.
Thank you, Matt. Can you talk about the API gateway deployment models a little bit? Whether or not you would recommend on-site or versus on the cloud deployments for the API gateways?
Okay, so if you've got your production running on-premise versus in the cloud and using your API?
Hybrid model, yeah.
A hybrid model?
Yeah.
So and you're talking about, hybrid model where you've got a mix, but you still got your API gateway running through like Amazon's or Azure's API managed gateway for you?
I'm just asking basically what are the best practices for deploying the API gateway? Is that like usually on-premise deployment or is that like part of the
I mean, personally, it depends, but personally, I guess I'm cloud biased, so I'm going to say, yeah, I would run your API gateway within your cloud provider because they're going to look after a lot of the management for you. And then really the biggest thing on hybrid that I consider is latency between the two. So what's your it depends what you're running. Like maybe your front-end code and that is up in the cloud. Maybe your databases are on-premise. Your PI data, that sort of thing, you're trying to keep in-house. Maybe that's the reason for hybrid. And what's the latency between those? So I would sort of, as the path that I would tend to go with, and like I said, I'm just talking general, would be your API gateway for traffic to flow through there into your cloud environment. And then your on-premise, you'd have like an express router, VPN, a direct connect, whatever it is, depending on your latency, back to your on-premise. If we were talking about like doing controls of access through your on-premise up to the cloud, doesn't come up for me that much, so I wouldn't be able to like go into that in much depth. But yeah, I definitely happy to go through in more detail around that sort of architecture if you want, and if anybody's interested around API gateway. It is hard. There's so many different services to like drill down on, sort of thing. I was like, do we pick one good method and drill down on that? But there's so many different services out there. I thought I'd give everybody just a taste. Assume that everybody kind of has a inkling of serverless and the cloud providers out there. Does anybody else have any other questions? All right. I hope this sort of overview, introduction to things to be aware of has been useful. If you do like API gateway and that want to get into deep diving with me, I'm happy. I'm going to be actually at the Scalar booth around the corner for the next half an hour or so. Happy to get into discussions. Also, if you want to find me, I run a meetup here in Vancouver for the last few years. Been running one at Code Core. We talk about all things cloud. Also run an Azure user group in Seattle. And then, yeah, we're doing a lot of podcasts and that on cloud topics every month as well. So happy to go over any topics you like outside afterwards in more depth. And thanks for having me.